This is going to be combined presentation along with some other feedback that I have received. So for some bit of context, I have recorded 3 presentations in the past that I have shared with the CS team in particular. But now that we have this new TAM CRE team, so this is like a presentation which combines all of the presentations in the past with some new added information as well. And right off the bat, I'd like to say that I want this to be as interactive as possible. And so please feel free to stop me anytime. And I'd also like to, get some general thoughts and questions around like, okay, if this is an incident, how would you react, or how would you use the tools we have currently available to debug whatever set performance issues, right? Okay, so to start off, I should clarify the scope that when we talk about performance here, we are mainly discussing server-side performance, because as you all know that like there is the web app side of performance, there is the mobile side of performance, but in this presentation, we are mainly going to focus on the server-side part of performance. Okay, so first off, I'll just quickly go through some of the tools we have available that helps us to understand or look deeper into any sort of performance issues, and then dig a bit deeper into Grafana, because Grafana is the main focus of this talk. So Grafana will take the larger chunk of things, but we need to have a sort of establish a common page and discuss all of the tools we have first, and then we'll dive into Grafana. So tools, of course, number one is we have CPU profile, and whenever you have high CPU, take this profile, share it with the developers, and that will give you an understanding of which part of the application is consuming the CPU, and that's straightforward enough. Similarly, we have the heap profile, needs to be taken whenever there is a memory leak or a memory spike. And the interesting part is like, of course, the recent incident we had where a customer had out of memory and the process crashed. So like if the process already crashed, and it's too late. But this is like, of course, like when there is a memory leak, then you have like a much larger window in which you can go and run this command, or when you have like memory spikes, or when it's like suddenly from one release to another, the memory has jumped up, right? Then if to figure out what is the difference or why is it taking more memory, then you can take the CPU. Next up, we have another interesting tool, which is useful to find out or to debug whenever you feel the server is stuck, or whenever there is a go routine deadlock in the server. So in the past, this has been useful to detect a very intricate deadlock we had in our WebSocket handling code. And yeah, this was helpful. So yeah, to get that stack trace, you send this or ask the customer to run this. Or if you do not want to kill your server, you can just use this and it will give you like a live trace of all of the go routines. Even this is helpful to understand what go routines are at what state. So for example, we have had an issue in the past where, of course, it was my bug, where like it was related to the cluster handling, where one request, it was the config save request, where you would save the config. That request would reach out to all of the nodes in the cluster, and then the response would come back. And then there was a deadlock in that code. So what was happening is that the config save request was never finishing, right? It was timing out. And due to the way the code was written, it was showing up as like a network timeout from the cluster code. And the config save was successfully saving locally, right, in the node from where the request hit. So naturally, you would think that, oh, okay, there is the network is slow, or somehow the clustering protocol is not working. So I asked for like, okay, is the network right? Are there any like clustering health checks, that sort of stuff? Is that failing? Everything was fine. And then when we actually got this go routine trace, then I realized that, oh, okay, like there is a deadlock which is happening in the clustering code, because of which this config save is not happening. So yeah, this is helpful in that sort of scenarios.
Quick one, Agneva. There's a question on if these are in a doc, or gist for easy actions.
Yes, of course. Like this, all of this I have went through it. I don't remember in my first or second presentation. So yeah, it's all there in that presentation. And of course, I'll share the slides. So yeah, no worries on that.
And then Ben Schumacher, I think you had your hand raised earlier.
Sorry, I cannot see the hand raise or any chat. So Jason, yeah, please feel free to.
Okay. Yeah. So in order to get the go routine trace, but also get memory information, CPU usage, the customer has to actually get on their MetaMask server, fetch that information from localhost. That's a bit of a hassle. Would that be something that we would include in the support package that we have right now, where we already include a lot of configuration values, and maybe that's also a good place where we just throw in the heap information and throw in the CPU usage from like, I don't know, 5 seconds ago. So we have a rough understanding of what goes on that machine.
Yeah, it's doable. Yeah, and technically there's nothing stopping us. It's just that, like, I don't know, the support packet would turn up like, okay, like give me everything possible, all possible information you have. And like sometimes we know that we ask the support packet of like, okay, like it's in non-performance oriented scenarios as well, just to get like a general understanding of things. But yeah, I mean, I am 0 out of 5 on this. If the support team feels it's helpful, yeah, of course, like, and like, yeah, technically it's pretty simple, just to, just get an HTTP request, collect the response, and attach it to the support packet. Yeah, so should be fairly straightforward. Any further questions? Okay. Right. Okay. So one more thing we have is we can also analyze how the SQL query is performing. So now we are getting more into the database side of things. Previously, all of these CPU, heap, go routine things were more on the application side of things. Sometimes it can happen, and it has happened a lot, is that especially in MySQL cases where we have seen that a particular query, it is happening fine in our dev environment, and it has been happening fine in community. Now community is no longer in MySQL, but anyways, but in certain situations, in certain customers, always we have seen that some particular MySQL query would behave very poorly, right? And then in those cases, to understand why that's happening, you would need to run something like this. You would need to run this command, explain, analyze, and this is the same in MySQL and Postgres both. In Postgres, you have some other options as well, but yeah, basically explain, analyze, and then the query which is not performing well. But the step before that, we need to find out what SQL queries are performing slowly, right? So usually, like, there are various ways you can get this. Like, okay, you can look at the Grafana graphs and you can see that, okay, this API is or this store method is performing poorly, but a lot of times that is not granular enough, because a given store method can actually run multiple SQL queries in a single transaction, and then you don't have the visibility of exactly which query is taking how long, right? So in those cases, getting the slow query logs from the database is very helpful to really dig deep and understand exactly, okay, this is the query which is taking 10 seconds, and then you get the query and then ask the customer to run extend analyze on that query. Yeah, and then the fun part is debugging that and understanding why this is happening, and then coming up with a dot release or whatever. They usually what has helped in a lot of situations, especially in Postgres, is we just ask the customer to run a vacuum analyze of that given table, which is slow. Sometimes it helps, sometimes it does not help. And like if it does not help, like, okay, maybe the table is too large, or maybe that there's some obvious problem in the query itself. For MySQL, there is also a command like optimize table, but in my experience, I have seen it actually benefit only once, and that too also in our community environment. And like, so optimize table is a bit of a hit and miss, and also it takes a super long time to run. So not very helpful. But yeah, vacuum analyze is a helpful command for Postgres. Okay, so
Avneet,
finally,
question here.
Yeah.
So basically, I guess, for slow query logs, the default time interval is 10 seconds, right? Queries running long,
are
10
you talking
seconds.
about MySQL or Postgres?
Yeah, MySQL. If you talk about MySQL, so like, is there any recommended, parameter we can set? Like, it has to be 10 seconds. We should recommend the customers to stick to the default limit, or we can, probably ask them to increase the time limit to, help in
10
better
seconds. Yeah, 10 seconds. So 10 seconds, I think it's a reasonable threshold, unless like everything is super slow, in which case like the slow query logs has like super like lots of queries, then you would try to bump it to 30 seconds. But I mean, I have the link here, so like if you can, if you want to take, I'm not exactly sure if the default is that, but 10 seconds, but 10 seconds I would say is a reasonable threshold.
Okay, thank you.
In Colton, you are mentioning you sometimes use 1 second as well.
Yeah, I was just saying, I usually set mine to 1 second when troubleshooting with slow query logs, just so you capture everything, and then you can work backwards and identify what's slow and just kind of see everything. It's a lot of stuff, like Agniva said, but it gets a little bit better insight.
Whatever works for you. So these are just the tools. Feel free to use them however you feel like. You are the ones who interact with the customers. So yeah, no, nothing that I have to say. There's 1 second, 0 second. Choose whatever you want. All right. Okay. So yeah. Now we come to Prometheus and Grafana, and from this point, we'll delve deep into this sort of stuff. But okay, so all of our Prometheus metrics are specified in this file. So I would recommend all of you to just go through this file and try to understand all of the metrics we have, right? Because that is the basic fundamental step in understanding where to look for, or which component has metrics available or not available, right? And of course, you have your API latencies and database store latencies, and getting the P50 and P99 metrics are the most common ones to understand what is the variation in the latencies for these metrics. And also, I would recommend everyone to go through the Prometheus documentation to understand what sort of functions are there. Because if you just take a look at this, you will just see like a list of like, okay, histogram, gauges, counters, vectors, and then you would be a bit lost, as in like, okay, histogram, how do I actually use that, right? How does a histogram actually translate to a P99 of a given metric, right? So you need to actually read both and have a good understanding of what are the various functions or queries available via Prometheus to really translate the metrics that I have into helpful Grafana queries, right? And you need this very much to really create custom queries on the fly when you are debugging a customer issue, right? So, for example, we have the V2 dashboard, which I'll go through in detail later. So the V2 dashboard should be considered like as a starting point for any of your performance investigation, right? And then if you are able to isolate to like a particular area of the problem, and then from that point onward, you should be able to create custom queries to dig deeper into a specific component of the issue to be able to isolate better, right? So to be able to create custom queries, you need to understand what are the Prometheus functions and what are the metrics we have, right? So, for example, a very common thing that I see in any normal any normal performance investigation is we recommend to disable the typing messages, right? Okay, it's fine, but how did you come to the conclusion that typing messages is the one causing the bottleneck, right? Where is the proof, right? The proof is in the Grafana graphs, right? So some Grafana metrics would show spikes, and from then you would be able to definitively conclude that, okay, like we can see that the WebSocket message is the bottleneck. We can clearly see that in this timestamp, there is a spike or it's consistently high. And then we know that among these WebSocket messages, typing messages is 90% of them, right? Or for example, 50% of them. So then we know that like disabling these typing messages, which is 50% of all of the WebSocket messages, will lead to a clear removal of the bottleneck, right? So this is how you clearly identify, okay, what exactly is the bottleneck, and then you are much more confident in your recommendations rather than just groping in the dark. Say, hey, can you disable this? Can you disable that? Oh, last release we had this. Okay, why don't you disable permalink previews or things like that, right? Okay. Before diving deep into the Grafana dashboard, I just want to give a brief detour in Loki and Thanos because it was requested. Let's check. Okay, we are still on time. So, what is Loki? So Loki, before Loki, we had the Logstash pipeline, which was Elasticsearch and Kibana. And we have had various problems with Elasticsearch, mainly because, okay, number one, AWS does not use Elasticsearch anymore. And number two, it was becoming a bit problem to maintain. And moreover, with Loki, it integrates very nicely with our Grafana ecosystem. So everything you can see in Grafana. So, okay, basically, you have these separate clusters. And so Promptail is an agent which collects the logs, and then it just sends the logs to the distributor and the ingester, and the logs are stored in S3. So this is one of the very helpful factors in Loki design, because the storage of the actual logs is just any general purpose storage, right? So it can be any like S3 or any cloud sort of storage, right? So this allows us to take backup and do all sorts of stuff, not relying on custom storage for logs, right? And yeah, so essentially all of the logs are forwarded via Promptail, and then it goes via distributed, ingester, and stored in S3. And then in Grafana, you have a querier wherein there is similar to how you make Grafana queries, you have to make Loki queries. The syntax is very similar, but slightly different. And yeah, then the querier just queries the storage, and sends in results. Okay, what is Thanos? So you know what is Prometheus. So Prometheus, the problem with Prometheus is that the one I was talking earlier, right? The Prometheus storage is its own custom format, and it's stored locally in the Prometheus server. It's that gives us various problems because it's hard to scale, right? So Thanos is like, okay, number one, it can work with multiple Prometheus instance. So I don't know exactly what is the distribution of Prometheus servers for our clusters. Is it one per cluster or multiple per cluster? I don't know. Sure. But the main differentiating factor is that now you have sort of like a Thanos agent, which queries from your given Prometheus server and then sends all of these metrics to again S3. And again, like once we store it into S3, then it solves all of our problem of taking backup. And then it's like a general place where you store all of the Prometheus metrics. And similarly, you have like your Grafana endpoint. So instead of directly hitting the Prometheus server, you hit a Thanos layer, which actually queries all of the metrics and gives you the result. There's also another part where you have an alert manager where you store all of the what rules you want to alert on, and then that's basically so so alert manager is something which Prometheus already has, and Thanos is just a layer on top of that because naturally now you have multiple Prometheus. Yeah, that was basically about Loki and Thanos. Okay, now
Quick question.
Yeah.
Do customers also need to use Thanos, or given that they like usually just have one MetaMask instance running and they don't need the scalability,
Right.
are they fine with just using Loki?
Actually, yeah, maybe people from the CS team can comment here. So I have known customers to use various different solutions for logs. I know one customer uses Splunk, some other customers uses some other things as well. But yeah, so far I haven't heard of any customer use Loki. But yeah, they can if you want to.
Thank you.
All right. Okay. Can you see the Grafana dashboard?
Yes.
Okay. All right. So this is the V2 dashboard, and I'm going to talk in detail explaining each panel and what everything does, so that you have an idea of you have a rough idea of what are the various metrics we have and how to, like, this should be, like I said, this should be the starting point, right? And from this point, after taking a look at the dashboard, you should have a rough understanding of where the performance bottlenecks are, and then dig deep by running custom queries, or if it's very apparent here, then that's fine. Okay, so this is the performance dashboard for ServiceNow. And as I've mentioned in a past R&D meeting, you can give the namespace for any customer, and that will just refresh. So, okay, these panels are very straightforward: HTTP requests per second, database calls per second, and okay, API latencies. So one thing to note, this chart is logarithmic. It is not linear. Why logarithmic? Because it is very easy to distinguish between P50 and P99. Right? Otherwise, like P50 would be absolutely down below and P99 would be very high. So it would be hard to see them clearly. And yeah, this is the same for store latency, P50 and P99. Okay, now we are coming to some more useful graphs. Top database calls by cup. Okay, so now how are we getting this top 10 database calls? So to dig deeper, we need to take a look at the variables, right? Okay, wait, first of all, I need to show you what this query is doing. Okay, so not much. It is counting the number of database calls made in the 5-minute interval, but what database calls is being selected via this level, which is top DB count. Top DB count is all. Now the question is, from how are we getting this list of top 10 database calls? So to see that, we have to go to variables, and top DB count is here. So this is the Prometheus query, which gives us the list of top 10 most called database methods in that time range. And this is actually passed on to this label here. And if you just select all, it'll just filter by that all of those entries that are there, right? So yeah, so this gives you an estimate of how frequently those database calls are being made. The reason why I chose top 10, it would be top 15, top 20. Yeah, feel free to modify that. The reason why I filtered that, because without the filter, it was becoming too large and it was not becoming it was becoming very hard to read. And the same thing we have for top 10 API requests by count. So these two are by count, right? How frequently a given API handler or a DB method is being hit. And this is by duration, how long it's taking. The same thing, top 10, we have for top 10, top DB count, top API count, top DB latency, and top API latency, right? The same way we are doing this for count. So this is also interesting because this gives you a visibility on how frequently a database call is made and how long it's taking, because those two might not be exactly corresponding with each other, right? A database query might be very fast and it might be queried very often, whereas some database calls might be very slow and it might be very rare, right? So yeah, you need both. So yeah, and that was yeah, go ahead, Ben.
One question, but neither of these two categories are the actual weight of the queries. So yes. Something like number of calls times duration.
Exactly. So in my community dashboard, I had that, but what I saw was that it was a bit it wasn't really as useful as I thought it would be, mainly because sometimes what happens is you get gaps. So for example, if I zoom in here, see, these graphs are broken. So if you multiply this with the corresponding time of the metric here, it sometimes it wasn't really super intuitive to understand what's happening. And then the thing is what I felt of course, if you want to see the weight, you can create the custom query and create a panel and ask the customer to see what's happening there. But what I felt was that these two separate graphs of how long something is taking and how frequently something is called gives you a very clear distinction of how something is behaving. Yeah, I had the weighted graph as well, but yeah, it was just that in my experience, it sometimes it was some graphs, some metrics. So one metric in your weighted graph would be broken, and then even here you can see that there are some not as numbered, right? So even these metrics, sometimes it is not very useful. That's basically why the weighted graphs are there. But yeah, if you want, please, more than welcome to ask the customer to create a panel and then look at what is the weight of a given query. Okay, now we have covered most of the high level stuff. Now we will go a bit into WebSocket stuff. Okay, so this is the graph of the WebSocket broadcast queue. What is a broadcast queue? Without going too much into details, so every time you create a WebSocket event, it needs to be sent to all nodes in a cluster, and also it needs to be sent to all of the connected devices. Now, a WebSocket event might also have scope, as in if you are typing a post in a DM channel, then that post event should only go to that particular user, not everybody, right? But if you have joined the channel, then that person X has joined the channel should go to all members who are part of that channel, right? So depending on that, the number of events can be more or it can be less, the number of total events, that is. But a broadcast queue is the global queue where the first event is generated. So if you have joined the channel, then that join channel event, initial event, will be in that broadcast queue. And then you have individual queues for each connected client. That is your, maybe call it sub queues or whatever. And broadcast queue is the global queue from where it spreads out to individual queues. So why is this metric here? So broadcast queue is normal cases, it needs to be absolutely zero, because we do not want any blockages in the broadcast queue at all, right? Because the moment something goes in the broadcast queue, it is distributed to all of the sub queues for each client, right? But if you see high values in broadcast queue, that means this is an indication that events are not going through, right? There can be various causes. Cause one, there is too many number of events being generated, or maybe all of the clients are slow, or maybe something else is happening, right? But this should give you an understanding of what is happening at a global level. Next, we have these two graphs, WebSocket broadcasts per second and WebSocket events per second. These are different, and the difference is very important. Broadcast is what is like the fan out factor. So if you have a single channel join event and you have 100 users connected to that channel, you will see 100 events here. So broadcast is the event multiplied by the fan out factor, and events is the actual event generated. So it can be that you have lots of events generated, but the clients for that events are very small. In that case, it might not be too much traffic. It can also be that the fan out factor for a given event is very large and a customer environment has lots of connected lots of concurrent WebSocket connections. In that case, the WebSocket broadcasts per second will be very high, right? So let's take a look here. So here we can see that status change, channel view, typing are more or less the top events here. But when you look at here, you can see that the user updated is actually sent much more often than your status change or typing, right? So in this case, if you disable typing, there won't be much impact, right? Because WebSocket, because user updated is taking most of a larger portion of the pie, right? So these three are the graphs that you can look at, analyze, and see if you are debugging any sort of WebSocket performance issues. And of course, this graph is total number of WebSocket connections. Okay, this is.
I think looks like Colton has a question.
Go ahead.
Yeah. Sorry, I have two quick questions. One, what is the query powering the broadcast queue chart? The broadcast queue one.
Oh, sorry. My bad.
It sounds relevant. Awesome. Okay. This is the buffer size one. Okay, cool. So then question number two for if you go back. So if you're looking at web,
if you don't have access to this, I highly recommend to get access to this.
Okay, I think I do, but I'll check.
Yeah,
but so for webcast broadcast per second, so let's say we're looking at this, we see user updated, has some spikes, and we want to troubleshoot it. How would you work backwards from what we see here to identifying what action on Mattermost is potentially causing this.
Yes.
If that derails you entirely, we can ask that
No.
later.
Good question. Because I actually asked this in the ServiceNow channel after looking at this, that, hey, we are seeing user updated events very often. So if you are well versed with the code base, what I did after looking at this is that I took a look at the code base, and then I saw what are the API requests which is actually generating the user updated. And there were like 3 or 4 places which I don't remember exactly now, but mainly promoting, demoting a user, or changing user names or things like that. It is not related to user status, by the way. That is something else. That is status change. So that was a bit weird, because like, okay, there is maybe like user nickname, that's a user profile data changes, or like, yeah, user guest to user or user to guest, that sort of changes. And then of course, like it's broadcast to everybody. And the fan out factor is like all connected clients. So that's one thing. But the thing is that user updated events are actually, so this is actual, yeah. So this is very low, right? The number of events generated are not that high, but since the fan out factor of user updated is so high, it is taking a large chunk of the overall events, right? So yeah, what I would do is like, I would reach out to the customer and say that like, hey, we are seeing a high number of user updated events, and these are the cases where user updated events are generated. Like, okay, do you have like customs, any script or anything which is changing usernames or changing guests to user, something like that? Yeah, I don't know. Like, but this should be like the starting point. And I don't know, if the customer says yes, all well and fine. If the customer says no, we'll have to take it from there. But yeah, the starting point should be take a look at the code base, see which API handlers are generating this event, and yeah, then just ask the customer and say that like, hey, we are seeing things like this. Do you know what's happening?
Perfect. Thank you.
If I may jump in with another question before we move on to other metrics. This is very helpful, the explanation, but also having these graphs. Are they shipping by default with the performance monitoring V2 chart, or are they custom ones that we have for cloud?
No. Absolutely nothing custom. It's my fault that like these 3 charts I have added recently, and I'm yet to update the actual grafana.com website JSON. But yeah, everything else is absolutely
okay.
Nothing customized to our cloud.
Thank you, because I was confused that I couldn't find them.
No, you can just go to grafana.com and.
Yeah, but these 4 aren't there.
Oh, yes. Okay, right. Yeah. My bad. It's on my plate. I need to update. Okay.
Thank you.
Moving ahead. I just have these 2 pre-built graphs because I feel that like these are indicators of how healthy your instance is, because like usually like loading a channel or creating a post is one of the most common activities that users would do. So like if you see like sudden spikes here, then of course like something is going wrong. And then okay, now we are moving to a bit of database stuff.
Hey Agniva, sorry, quick question on the create post and or load channel, the create post. So I'm not sure if this is from some of your own load testing.
This is live production service now.
This is going on right now. So when the context for me is we've been looking at doing a proactive health check type engagement with customers where we talk to them and we look at their Grafana before there's actually an issue.
Yeah.
Like this on a semi-annual basis, maybe. We're still sort of mocking that out, but what I'm going through is like, okay, what are the kinds of things that we will look for as signals in the Grafana chart to potential concerns or something to double click on.
Mhm.
So in yours right now, if I was looking at yours, I go, what's like, do we need to be worried about 4-second channel load durations and 8-second create post durations? If this is our, so those are P99. So
Yes.
maybe don't, because maybe they're just slight aberrations and we accept that that's going to happen once in a while. Like what's the mindset for you when you look at,
Yeah, good question. So typically I would take a look at both P50 and P99 both and see like, okay, what's the difference between the two, right? So in this case, I can see that P50 is mostly healthy, 40-50 millisecond. Okay, not too bad here. And sometimes P99 is spiking, and P99 is not spiking always. It's just, okay, sometimes there are brief spikes, and then mostly it's around 250 millisecond. 250 millisecond is perfectly fine. Where I would be concerned is if it's like consistently flat, right? Which is how you would see in Bank of America's this same channel load duration. Like consistently flat and hitting a ceiling means it's timing out, right? And it's timing out and it's just standing there. That is a problem, right? And that is when you would need to, either look into the query or look into the database or try to optimize. But otherwise, this is of course not super ideal, but it happens, right? We know that ServiceNow is a large database. It has by now it has around 15 million. So it can take some time. There are periodic spikes, but P50 looks more or less healthy. So it's okay. And let's see, create post actually does a lot of things. So create post is not, so this is bear in mind, this is API level. This is not database level. So at API level, for creating a post, you do a lot of things. Like there is for CRT, you need to calculate like mentions, you need to parse hashtags, calculate who will get how many, what push notifications, email notifications, a lot of stuff. So create post is usually high, but again, still like nothing is flatlining here, and like there are periodic spikes, but again, like it's coming down, and you more or less it's at 1 second, which is fine. Okay. We also have a metric for replica lag. If you want to monitor what the replica lag is, I won't go into too much details here, because to set up replica lag, first of all, you need to create the query which will give you the replica lag value, and that query needs to be defined in config.json, and this will just run that query and plot the value here. We used to have that when a community was on MySQL. And so if you're asking what a decent or a healthy replica lag value is, that would be between 15 to 20 milliseconds, we have seen, and typically on Aurora as well. So anything, of course, like if it goes to 1 second, it's not good. Database connections, fairly straightforward, number of master and replica connections. Now, okay, this is a useful chart where we look at the connection pool. This is useful in understanding what should be your max open connections, max idle connections, max idle time, and don't think I missed it. So here you can see that the green one is open connections, and then the yellow one is in-use connections. So as you all know, Mattermost, the application uses a connection pool, right? So it will open a certain set of connections and it will keep them open. And at a given point of time, only a certain subset of those connections will actually be in use, right? So if you see like a healthy gap here, that means like a connection pool. This is like a healthy connection pool, right? If you see this yellow chart going close to the green one, that means like we don't have enough connections in the buffer, right? That means what we can do is, that means we can either increase the max open cons or we can increase the max idle cons, right? it depends on like how everything is configured. But the key takeaway from here is when you're taking a look at this graph, there should be a difference, like a healthy gap between this, which will indicate that like, okay, we have enough connections in the pool, and there shouldn't be any spikes of this blue one. Wait count means when you get a request to get a connection, then the connection pool will give you like a connection, right? If the connection, if it has an already opened idle connection sitting, it will hand it over to you. But if it has run out of connections, then it has to create the connections with the database and then hand it over to you, right? So in some cases, when you have like sudden spikes or like huge influx of requests, then you would see this wait count increasing. And if you have consistent spikes of wait count, that means again your connection pool is misconfigured. So either you have to bump up max idle cons or max open cons, so to let these spikes of requests being handled from the pool itself, rather than again going to have to hit the database, create the connection, and then give the response back. There are also other metrics like max idle closed. So this indicates the number of times connection has been closed due to the max idle cons limit. This also should not be very high. If this is very high, that means your max idle is too low, right? That means if your workload is using, let's say, 50 connections, but you are allowing only 10 connections to be idle. So in that case, you would need to increase your max idle to be 50. And this is also max idle time, where we define the max idle time. Max time a connection can be idle. Yeah, this should also be low. If this is high, that means your max idle is too low. You need to increase that. Yeah, that was about Replica and Master.
I saw your hand was raised earlier.
Well, I was going to ask, but we only have 10 minutes. So I'll save it for another time. It's okay.
Yeah.
Well, I need to get through the agenda. Thanks.
Okay. Yeah. I had some more, but we ran out of time. I'll try to squeeze past this quickly. Cluster health. If you see this spiking above 0, like 1 or 2, that means the intra-cluster communication is not working, causes maybe a node is down or maybe something is not right. Ideally, this should always be 0. If you see this spiking, you would also see spikes here because both of these correlate. Yeah, this is the cluster request duration, because as you know, like for example, the config save example I gave earlier, you would have seen spikes here because like the config save is not finishing, it's timing out. So you see spikes in this. This also the request per second, number of jobs we have. Pretty straightforward stuff. CPU, heap, Go routines, not much to see here. Yeah, so this was mainly about, this was just like a brief walkthrough of the V2 dashboard we have. Again, this should be your starting point to give you like a brief visibility of how a system is performing. And yeah, from there, you need to dig deep and see what's going on. Okay. In the brief 9 minutes we have, let's see if we can finish this. I had two items here, but I had to skip one. Okay, so how we have learned a lot about Grafana, CPU profiling, heap profiling, all of this. And so I just want to run through like a sample incident and put all of this into use, right? Okay, so sample customer escalation, users are experiencing slowness loading channels. Please help me. The first question would be, okay, sorry. So the approach would be to eliminate different aspects of the problem till we isolate the root cause, because there can be various parts to this, and sometimes customers are not very specific into saying what a problem is. The customers will say problem is X, and then you debug and realize, oh, okay, it's Y, right? So first question is it server side or client side, right? Because it might be that one client's network is slow, and that's why channels are loading slow. So okay, before that you would ask that, okay, you are saying channels are loading slow. Are all of your clients saying that, or is it only one client saying that? Is it happening only on one channel, or is it happening on all of the channels, right? And so after you have asked this, and let's say assuming the answer is that all of our clients are experiencing this and it's happening on all of the channels, then you get a better idea of, okay, it's happening on all of the channels and everybody is experiencing this. So if everybody is experiencing this, that means it's not likely a client-side problem, because if it were a client-side problem, then it's very improbable that client-side network of all connected clients are slow. Maybe it is, don't know. So in this case, the way to isolate this would be you ask hard profile while loading a channel from a given client, check the time, and then also check the P50 and P99 times of the channel load duration and compare them. If P99 is 2 seconds and the actual client side channel load duration is 30 seconds, that means the problem is client side, right? If it's more or less comparable, that means it's server side. Okay, so assuming that if it was server side, then we dig into how did it start? Is it now? I'm assuming that you have the Grafana panel open and you're looking at that. Then you would ask the customer that, okay, I'm seeing some spikes here. So like, did you make an upgrade recently, or did it just start to happen randomly, right? And yeah, I covered this. Okay, now let's say that you are seeing a spike and it's not an upgrade, it just suddenly started to happen, right? Then the problem is then the problem starts to get serious, right? That means it can be one of a few things. It can be that the database wasn't very healthy to begin with, and it's just started to degrade, and now it's fallen off a cliff, and now we are noticing these issues. And or maybe it's some infra-related problem. We don't know. The thing is, if it was an infra-related problem, then all other endpoints would also be slow, right? Then you would check that, okay, let me check other endpoints. You would make queries that, hey, can you check this one? Can you check this one? If you see spikes in all of them, then you would know that, okay, it's not just the channel load which is slow, it's other endpoints which are also slow. If that's not the case, that means, okay, then the problem is fairly straightforward. Then it's just this channel load SQL query which is slow. Then what you would do, then you would get the SQL query from the code and then ask the customer to run an explain analyze. Because we have isolated everything else and we have eliminated that, okay, it's not an infra-side problem, it's also not a problem related to an upgrade, and randomly we are seeing this particular SQL query behaving badly, and it's just this SQL query, none of the other SQL queries are performing poorly. So yeah, at this point you would run explain analyze and take a look at why is the query behaving slowly. I don't know, you'll have to analyze that and see. But again, rough rule of thumb is if it's Postgres, what we have seen is usually vacuum analyze of that table helps. You might ask the customer that, hey, just to throw this in, maybe you want to run this and see if that improves. If it does not, then we need to dig deeper. If it does, yeah, then that's fine. If it's MySQL, yeah, we need to see, depending on what the query does, and maybe it can be that the size of the table is now too large for the query to be returning in a given time range. So maybe the database needs to be upscaled. But then also, like, if the database is the issue, then all other queries should also be slow, right? And we just clearly saw that that wasn't the case. So in this case, it seems to be that this particular SQL query is somehow slow. Yeah. That would be basically where you would dig deep into, and then it would be basically up to the developers to understand why the query is slow and didn't fix. But yeah, this should be like a rough steps to first isolate various aspects, eliminate any other things which are not related, and then they dig into the actual issue and find out what's the problem. I also wanted to run through another incident, but yeah, we don't have time. So, any questions? By the way, if you have to take away anything from this presentation, I would recommend to just focus on these Prometheus and Grafana queries. Take a look at this file, go through all of the metrics, understand what each metric does. If you don't understand, look at the code from where it's being called, and go through the Prometheus documentation as well, understand how the various types of queries are being used to get the useful results like histogram, gauge, counter. It's very easy to make an incorrect query, and because it will look more or less the same, right? If you have like a decent graph, you might think that, this is the output that we are getting, but it would be a totally wrong conclusion. And I have done that in the past when I was setting up all of this Grafana graphs. So it's very important to understand how these Prometheus queries work. And yeah, once you know all of this, it should be pretty straightforward to create custom queries and understand how Mattermost is behaving. And if you don't have access to these, please do take a look, and you will see that at various moments of the day, this is past 12 hours. Let me take a look at past 24 hours. Let me see. Yeah. Okay. Now look at this. So you can see I actually talked about this in an R&D meeting in the past, but yeah, just something that is visible from the Grafana graphs, right? Top DB calls by duration. You are seeing that, okay, there is a certain spike here. Why is this happening? If you zoom into this, you will see that, okay, it is a delete orphan rows and batch delete for retention policies, which means it is the data retention job, which is behaving slowly. And you can confirm this by this active checklist, right? So this is also another example where we are correlating multiple panels and then identifying that, okay, this is, you can actually dig deep and see the name of the job, because I'm grouping by instance here. You can also group by the name of the job. And see that this is the data retention job running here. And exactly at that point, these queries are becoming slow. So yeah, that's it.
Excellent. Thank you, Akiniva. If there's any questions, we'll share the slides, we'll share the recording, and there's been a couple of links shared in the chat too as well. We'll share those in the CS technical channel. If there's any follow-up questions, please share them there. And Akiniva or myself will follow up with you. So thanks again, Akiniva. I really appreciate it.